Lesson 11, I will connect the area model and partial products method to standard algorithm. So the very first multiplication strategy that we learned in this module was partial products, and then we transitioned from partial products to standard algorithm. Well, today in your Zern lesson, you also learned about the area model. And you might be thinking to yourself, well, why do I care about this other strategy when I've already learned standard algorithm? The reason why we're learning about this area model is because when we get ready to do this, 2-digit times 2-digit, we're going to use this area model to help us to understand. So right now we're starting with 2-digit times 1-digit so that when we get ready to add another digit, it's going to make more sense. All right, so go ahead and write your name at the top of your problem set, and let's take a look at the directions. It says solve the following expressions using standard algorithm, partial products method, and the area model. Okay, so first of all, you can see here that we have an area model. I'm going to start over here first. So it looks like we have a width of 4, and then we have a length of 400, 20, and 5. So what is 4 hundredths times 4? Well, that would be 16 hundredths. 2 tens times 4 would be 8 tens. And 5 ones times 4 is 20 ones. Okay, so you can see down here, they have all of the lengths added together. So we have the total length of this rectangle is 400 plus 20 plus 5. But we're using the distributive property. We're taking 4 times the first number, which is 400. We're going to add that to 4 times the second number, which is 20, and we're going to add that to 4 times the last number, which is 5. So that's what we did here inside of our area model product. Okay, so now all we have to do is add all of our partial products together, and then we will have our answer. Okay, so let's come over here and record this as partial product. So I've got 425 times 4. And then I'm going to record my first partial product when I did 400 times 4, which was 16 hundredths. And then I'm going to add that to 20 times 4, which was 80. And then I'm going to add 5 times 4, which was 20. And when I add all of these partial products together, that's going to give me 1,000. Oops, I better start over here. 0, and then I'm going to carry the 1. 1,700. Okay, now we've already used the area model. We've already used the partial products method. Now we're going to go back to standard algorithm. So I'm going to just change colors here. I've got 425 times 4. And I want you to go ahead and pause the video and try to solve this using standard algorithm. Then let's come back and check together. Okay, so let's take a look. We've got 5 ones times 4, which gives us 20 ones. And then 2 tens times 4, which gives us 8 tens, plus 2 more tens gives me 10 tens. And then 4 hundredths times 4 plus 1 gives me 16 hundredths plus 1 is 17 hundredths. Now, which of these methods did you think was the fastest? I bet you said standard algorithm, and I agree. So you might be thinking to yourself, if standard algorithm is faster, it's more efficient, I can do it, why do I have to bother with these? But remember, the reason why we're doing these two strategies right now is because pretty soon we're going to be doing 46 times 48, which is 2-digit times 2-digit. And you can use standard algorithm, but it's a little bit more complicated. So before we get to standard algorithm, we're going to use these two strategies to help us to understand. So please bear with me. All right, so let's take a look at B. All right, so we've got 7. All right, we've got 534 times 7. I'm going to go ahead and write that over here to get ready for my partial products. 534 times 7. Now let's come over here and fill out our area model. So we know the width is 7, and we know that this big area is 500, and then we have this little section has a length of 30, and this small section has a length of 4. So we have 500 plus 30 plus 4, which is expanded form, right? 500 plus 30 plus 4. So if we're going to use a distributive property, we're going to take 7, which is the width, and we're going to multiply it by each of these smaller sections. So we're going to do 7 times 500. We're going to do 7 times 30, and we're going to do 7 times 4. So what is 5 hundredths times 7? Well, that would be 3,500. What's 3 tens times 7? 21 tens. And 4 ones times 7 is 28. So we can use these partial products to fill in over here so that we can get a total product. So first we did 500 times 7, which was 3,500. 3 tens times 7, which was 21 tens. And then we did 4 ones times 7, which was 28. And now all we have to do is add all of our partial products together. So we have 8, 3, 7, and 3. 3,738. So now let's try to multiply using standard algorithm and see if we get the same answer. I'm going to pause the video and I want you to try to do this all by yourself, and let's come back and check and see if we got the same answer. Okay, so let's take a look here. We had 4 ones times 7, which was 28 ones. 3 tens times 7, which is 21 tens, plus these 2 tens gives me 23 tens. And then 5 hundreds times 7, which is 35 hundreds, plus 2 more hundreds gives me 37 hundreds. So I have 3,738. Okay, so we did 2 of these together. I think that you might be ready to try to do one of these all by yourself. Now, I will tell you that you'll notice that this is a 3-digit number and you only have 2 boxes. If you can't figure out why, you can press play, but I bet if you think really hard, you can figure out why it looks that way. So let's pause the video. Try to do as much of this as you can by yourself. If you get stuck, you can always press play. Okay, so we had 209 times 8, and hopefully you tried to do as much of this as you can by yourself. So before we pause the video, we talked about why there are 3 digits, but over here in our area model, there are only 2 boxes. Did you figure out why? Well, it's because there are no tens. There are only hundreds and ones. So instead of having 3 digits, we just have, instead of having 2 areas, we only have 2, instead of having 3, we only have 2. So we had 8 times 200 plus 9, which is 16 hundreds, and 8 times 9 ones, which is 72 hundreds. And then I came over here and I recorded all of this as a partial product. I put my 72 here and I put my 1600 here. Now in the past we've been putting the 1600 first, and that's okay too. You learned from the Zern video. It doesn't matter what order you do these in when you're using partial products. Now it does when you're using standard algorithm, but when you're using partial products, it doesn't matter if you do 200 times 8 first or 9 times 8 first. So this time I just did 9 times 8 first. Then I used standard multiplication algorithm, and I had 9 times 8, which was 72, 0 times 8, which is 0, plus 7, which gave me 7, and 2 hundredths times 8, which gave me 16 hundredths. So I ended up with the same answer in both places. All right, so let's take a look at an application problem here. So we're going to solve using partial products method. So you can see they told us not to use the multiplication algorithm. We are using partial products. So I'm going to read, I'm going to draw, I'm going to write a number sentence, and then I'm going to write a word sentence. So Kayla's school has 258 students. Janet's school has 3 times as many students as Kayla's. How many students are in Janet's school? All right, I want to see if you can draw an area model, a tape diagram to represent this problem. Let's come back and see if we drew the same model. Okay, so I went back and I reread this problem, and I noticed that it said that we were comparing Kayla's school to Janet's school. So I decided to go ahead and do 2 tape diagrams. I went ahead and I labeled Kayla's school 258 students, and then I went ahead and made Janet's school with 3 258s because it's 3 times as many as Kayla's school, and then I put S for my unknown because the question says how many students are in Janet's school, so this is what I'm trying to find out. Now it says solve using the partial products method. So in order to figure out how many students are in Janet's school, I'm going to have to do 258 3 times, which is 258 times 3. And it says use partial products method. So we're going to go ahead and solve this using partial products. So if I have 8 ones times 3 ones, that is 24 ones, and 5 tens times 3 is 15 tens, and 2 hundredths times 3 is 6 hundredths. Now we just have to add this together. So that gives me 4, 7, and 7. So we read the problem, we drew a tape diagram, we wrote a number sentence. Now we're going to write our answer as a statement. How many students are in Janet's school? So we're going to say there are 774 students in Janet's school. Okay, let's take a look at number 3. All right, so this time it says model with a tape diagram and solve. So we have to draw a tape diagram that models 4 times as much as 467. Okay, so we've got, let's go ahead and draw our tape diagram. What do you think it would look like if you were going to show 4 times as much as 467? Well, that sounds to me like 467 4 times, right? So that's going to be 467 once, twice, 3 times, and 4 times. Now you'll notice it doesn't tell you how to solve, so you can use whichever method you prefer to solve this problem. I'm going to pause the video and I'm going to solve the problem, and I want you to pause the video and I want you to solve it. Choose the way that makes the most sense to you. Okay, so I chose to use standard algorithm because I can do it pretty quickly and efficiently. So I did 7 ones times 4, which gives me 28 ones. And then I did 6 tens times 4, which gives me 24 tens, plus 2 tens, which gave me 26 tens, and 4 hundreds times 4, which gave me 16 hundreds, plus 2 more, which gave me 18 hundreds. So I ended up with 1,868. All right, let's take a look at 4. It says solve using standard algorithm, the area model, the distributive property, or the partial products method. So you get to choose which of these strategies you want to use. You can use standard algorithm, you can use area model, you can use distributive property, or you can use the partial products method. So I'm going to pause the video and I'm going to come back in a second, and then I'm going to have you check. I'm going to show you the answers to all of these methods, but you only have to do one of these methods. Okay, so I'm going to start with standard algorithm, which I have a feeling is the strategy that most of you used. When I did 5,131 times 7 using standard algorithm, I got 35,917. I only ended up with one place where I had to bundle. I had 7 times 3, or 3 tens times 7, which was 21 tens. So I had to add that to 700s. And then I did the same problem using partial products and the area model. So here's my area model. I have 5,000 plus 100 plus 30 plus 1, and I multiplied it times 7. Here's where I use the distributive property. I had 5,000 plus 100 plus 30 plus 1, which was all times 7. So that's the same thing as 7 times 5,000 plus 7 times 100 plus 7 times 30 plus 7 times 1. When you add all of those partial products together, you get 35,917. So I've already said this once, but I'm going to say it again. You did not have to do this all of these ways. This word or tells you only had to choose one way. So it was perfectly okay if you only did standard algorithm.